How did early Internet protocol networks handle QoS challenges? Imagine trying to send a voice call or a video stream over a network that treats all data equally. That was the challenge early Internet networks faced when managing quality of service. Back then, the Internet was built mainly to send simple data packets reliably, not to prioritize certain types of traffic. This made it tough to support applications like voice calls or video chats that need steady, low-delay connections. Initially, the Internet used a best-effort delivery system. That means every data packet was treated the same, with no guarantees on speed or delay. This worked fine for basic file transfers but caused problems for real-time services. As more multimedia applications emerged, the need for better traffic management became clear. To improve this, engineers experimented with different methods. One early idea was to add type of service bits in the IP packet headers. These bits aimed to tell routers which data was more important. Unfortunately, many networks ignored or didn't properly implement these bits, so they didn't make much difference. Another approach was the integrated services architecture. This system tried to reserve resources for specific data flows. It involved signaling protocols to request and maintain these reservations. While this method could ensure performance for certain streams, it was hard to scale because routers had to keep track of every flow. This made the system complex and fragile as the network grew larger. Then came differentiated services, which marked packets with priority levels using code points in the IP headers. Routers could then handle high-priority packets differently, reducing delays and jitter. Unlike the previous method, diffserv didn't guarantee perfect performance but aimed to improve the experience for important traffic. Still, it faced hurdles because service providers didn't always want to implement or enforce these markings across their networks. At the same time, lower-layer technologies like frame relay, asynchronous transfer mode, and multi-protocol label switching provided QoS features at the data link or network layer. These were mainly used in private or enterprise networks, not across the entire public Internet. The main difficulty with deploying QoS early on was not just technical but also economic. The Internet was designed to be decentralized and simple, without centralized control or billing systems for differentiated services. Service providers found it hard to justify the costs of implementing QoS because they couldn't easily charge for it or guarantee performance across different organizations. Because of these challenges, the early Internet stuck with the best effort model. It was easier to scale and maintain, even if it meant sacrificing some performance for real-time applications. Over time, as digital and industrial revolutions pushed for more reliable multimedia services, new standards and technologies continued to evolve. But the initial efforts to handle QoS showed how complex and interconnected the development of Internet protocols really was.